Okay, so in this video we're going to see how we can set up a proportion to solve for a missing side on similar triangles, and then we're also going to write a similarity statement to show that these triangles are similar to one another. In order for triangles to be similar, they have to have congruent angles. So all three angles would be congruent, but we just call this the AA postulate. And the reason why it's called the AA postulate is because as long as I have two of the angles being congruent, then the third one also would have to be the same, because on a triangle, it'll have to equal 180 degrees. So let me show you what I mean by that on this picture that you're looking at here. So we have two triangles in this picture, and it might be a little bit difficult to see, so what I'm going to do is I'm going to outline the smaller triangle first. So here's our smaller triangle. Okay, now I'm going to erase that to show you the bigger triangle that we're looking at here. Okay, so those are our two triangles. Now, we know by looking at the picture that they both have 90-degree angles. We also know that right here they have angle A in common on both of the triangles. So if I know that one of the angles is 90 degrees, and let's say that angle A down here at the bottom, we'll say, for example, let's say it's 30 degrees. I'm just giving this as an example. It probably or isn't necessarily 30 degrees. So if that's the case, that means the third angle, for example here, angle D on the larger triangle and then angle C on the smaller triangle, those are going to have to be congruent to one another, because if I were to add and figure out what this other angle would be, it would have to be the same on both of the triangles, since the interior angles of a triangle will have a sum of 180 degrees. All right, now let's go ahead and see how we can set up a proportion to solve for the missing side length here. So what you would do is you would look at the sides that are corresponding to one another, and we're going to set up a proportion. So, for example, side CB is going to correspond with side DE on the bigger triangle. So I would set up my proportion that way. I could say 4. I could put 4 and x both in the numerator, or I could put 4 in the numerator and x in the denominator. You just need to make sure that the way you're setting up the proportion matches your picture to where you're matching up the corresponding sides. So then what I could do is, let me highlight the other one. We'll do green. So here I have the 6 at the bottom on the smaller triangle from A to B, okay? And now from A to E on the larger triangle is this complete distance here. So I drew it underneath just so you can see the difference. On the smaller triangle, we're looking at the value of 6 for that side length, but on the bigger triangle here, we're having to take the sum. So 6 plus 5 is going to give us 11. So that would be our denominator on the proportion that we're going to set up. I'm not going to solve that because I'm going to solve one on this next page right here in a second. But this is the proportion that you could use in order to solve for x. I want to show you that we can write a similarity statement by naming these two triangles. So for example, I can say triangle ABC is similar to triangle AED. Now I want to make sure that I'm putting those letters in the correct order so that they're matching on both of the triangles. So I'm matching up the corresponding sides. So this is showing me that my two triangles that I see here in the picture are similar to one another. Now you could have written it you could have written the letters in a different order as long as you're making sure that it matches up correctly. So let me give you an example of what I need. Another possible statement that you could have written was triangle BCA is similar to triangle EDA. So that's another possible one that you could do. Okay, sorry, let's go back to the others. So on this one, we want to ask ourselves, you know what, actually, let me go back. So on this slide, what we're doing is we're looking at, again, two similar triangles. And the way that I know they're similar is because I know that they're both right triangles and they have this angle down here in common. And having two congruent angles is enough for me to know that these two triangles are going to be similar to each other. And because I know that they're similar, when I set up a proportion with the corresponding sides, I should be able to solve for the value of a missing side. And because they'll simplify to be the same ratio. So let me show you one possible ratio that you could set up here. So here we know that this side of 6 is going to match up on the bigger triangle with this total distance down here. So I want you to think about what that would look like and how I would write that. And then this side length of 5 would correspond to the side length of 14 on my bigger triangle. So now whenever I'm setting up my proportion, just realize here that the bottom side, this total distance right here, would have to be the sum of 6 plus x. So you're going to reflect that in the proportion that you write here to solve. So I want you to pause the video right now, try to solve this on your own, and then press play and see if you got it correct. All right, I'm assuming that you paused the video and that you tried it on your own. Here's one possible way that you could set up the proportion to show that these two triangles are going to have corresponding sides that'll be proportional to each other. So 5 over 14 would have to match up with 6 over the length of that bottom side of the larger triangle. So that's 6 plus x. So now what I would do is I could multiply across. So this is 14 times 6 is equal to 5 times 6 plus x. So this is something important that you're going to want to remember here since we have the parentheses right there. You need to distribute the 5 to everything that's inside of the parentheses. So here when I multiply, I should get 84 is equal to, when I distribute this 5, it's going to be 5 times 6 plus 5 times x. Now I'm just solving a two-step equation. So I'm going to subtract my 30. That's the bell ringing. Don't be late to class. Okay, now I would divide by my coefficient here. So 54 divided by 5 should give you 10.8. So that would be the value of this missing part right here. Now, if the question were asking, what's the length of the bottom side of the rectangle, the larger rectangle, okay? So like here's our larger, I said rectangle. I'm totally meant to say triangle. Sorry about that. If my question was asking, what is the length of the bottom side of the triangle, how can we figure that out? Well, if I know the value of x and I know part of the distance has to be 6, what I could do is combine that together. So 10.8 plus 6 gives me 16.8. Now that would be if it were asking for the entire bottom side of that triangle. Thank you so much for watching. Have a great day. Bye.